Hello, everyone. So at the help session today, there was some confusion regarding the wet bulb temperature and the dew point and how to read the psychrometric chart. So I wanted to go over the practice exam number 1 problem, go over that solution, and then clarify the wet bulb temperature so that everyone's on the same page. So for the record, for the most important part here, for the exam, wet bulb temperature is not going to be mentioned, but I just wanted to clarify everything because I have inadvertently introduced more confusion than is necessary. So in this particular problem, question part A asks, which of these following has a greater mass fraction of water in humid air, right? So what we're asking for here is a higher humidity ratio or higher absolute humidity, right? So what's the absolute ratio of water to dry air? That on the psychrometric chart is given by these points down here, right? Grains of moisture per pound of dry air or pounds of moisture per pound of dry air. Okay, so that's the key axis for this particular problem. So if we go back up to the question, the 2 points we want to compare are fully saturated air at 40 degrees Fahrenheit. So that's going to be the condition where you're at 100% relative humidity. So we can go down and we can see at 40, right? At 40 here, moving all the way up to 100% relative humidity, 40 there. Now at this point, the dew point and the wet bulb temperature are the same thing, okay? So we can look down and we can read all the way down and we can see that I've marked here what the humidity ratio of that one is, okay? So it's around, 30 to 40 grains. The second part here is 20% relative humidity at 100 degrees Fahrenheit. So there we go to 100 degrees up to the 20% relative humidity line. And then we can see that we can read down we're between 50 and 60 grains per pound. So in this case, the 20% relative humidity at 100 degrees Fahrenheit has more water contained within it. Okay, now to clear up the discussion that we had in the help session. So this is in part due to my poor understanding of the wet bulb temperature, but I have gone back, I have clarified, I have been using the chart correctly, but I had a confusion of the differences between the wet bulb and the dew point. So let me go over that really quickly. This is not going to be on the exam, but I wanted to clear it up anyway. So if we have, let's say, a 70-degree system at, let's say, 50% relative humidity. At this case, right, the dew point would be keeping the same ratio of water and air until it condenses, right? So the dew point of this system would be 50 degrees. So we can think of this like a closed container with water and with air in it. And then we reduce the temperature until we get to 100% relative humidity and saturation. So the reason why we're drawing a vertical line in this scenario here is because we're keeping the ratio of water and air constant, right? It's a closed system. Now, the wet bulb temperature of this system would be following these diagonal lines up to this point over here. And then in this case, the wet bulb temperature appears that it looks like 59 degrees Fahrenheit. So the wet bulb temperature is the same thing as I've said before, where you wrap the thermometer in some water, you swing it around, you blow some air over it, and some of that water will evaporate. So the reason why we draw the wet bulb temperature in line with the enthalpy measurements is because it's an adiabatic measurement, right? So we're not putting any heat energy into the system. So all of the energy that goes into evaporating the water is cooling off the thermometer, and the total enthalpy of the system stays the same, right? So you cool down the thermometer and that energy is taken away by those water molecules evaporating. So that's why the wet bulb temperature follows a line of constant enthalpy. So I was very worried that I had been misleading everyone into how to read the psychrometric chart. So I was teaching the psychrometric chart correctly, but I was not clear on my own side of exactly the rationale behind the design of it. So hopefully this clarifies things a little bit, but I'm not going to be asking any questions about the wet bulb temperature, so you don't have to worry about that. but I wanted to make this video to help clarify things. So in general, just to recap here, we have essentially 3 different points that we can look at. At 70 degrees, right, once the dry bulb temperature equals the wet bulb temperature, this is 100% relative humidity. In this case, if we're 50% relative humidity, the dew point would be measured up here at 50 degrees Fahrenheit. And that's because we're keeping a constant ratio of the amount of water to the amount of air. The wet bulb temperature is in between these 2 temperatures, and it corresponds to the temperature that the thermometer would be cooled down if all of the energy went into evaporating some water to get to 100% humidity. So the distinction that I failed to recognize or communicate well is that the wet bulb temperature and the dew point are not the same thing. So I generally don't use the wet bulb temperature in my daily life, so that's part of the reason for my confusion. Don't worry about the wet bulb temperature. I have been demonstrating how to read it correctly, but I introduced unnecessary confusion during the help session. So I hope this clears it up, but please ask me if you have any questions. There is not going to be any wet bulb temperatures, but do potentially expect a psychrometric chart question. Just forget about the wet bulb, okay? We can cover that a little bit later. I don't use it regularly, so I don't think it's necessarily a critical thing to commit a lot of effort into. But the dry bulb and relative humidity, that's a really common way to communicate information. So with that, hopefully I've cleared up confusion. Maybe I've caused some more, I don't know. Thank you a bunch.